So how do we cut two cylinders that, for example, intersect each other? It is a somewhat complicated task because you're dealing here with two objects that are curved. However, again, if you break it down into logical problems or modules, it is actually very easy. It looks intimidating at first, but the solution to it is quite simple. So what do we do, for example, to construct the cylinder? Of course, we create a box and then we project our ellipses into it. So we use our cube as a tool to build our cylinder. For example, I switched into kind of like a two-point perspective camera. So you see my vanishing points are left and right. Now to create the horizontal cylinder, we create another cube. On each face, we construct those ellipses so that with those ellipses, we can create the horizontal cylinder. Now, inside the computer graphics software here, you already see how those two cylinders are actually cutting each other. When you start sketching this by hand, of course, you don't know that. So let me show you what a really simple approach is to figure out, for example, this pink intersection line. As you can see, that is basically the way how those two cylinders would cut when they have exactly the same diameter. So let me go back to here for one step and let's show those sketches as well. Now your circles and your boxes are going to be your really best friends forever for even solving this problem. Because if I am going to hide this layer, you will see that I sketched in some additional lines. So you see, for example, from here, here's the midpoint where this circle or the ellipse is touching this face. And then from this midpoint, I am drawing a line to the vanishing point, and the same on the lower part. And for example, from this cube, from the midpoint, I draw vertical lines down. Now, as you can see, where this line, for example, goes to the vanishing point, this line goes down. Where they meet, that's actually a corner point. So you see? And the same, for example, is also true for the side. So you see, it's really good to try to see in your mind those objects from different positions. So from the front, you see it's a rectangle with a ring and 4 points. From the top, it's a rectangle, a ring with 4 points. And from those midpoints, lines going to the vanishing point, they will at one point cut the midline, which I draw from this upper ring to the lower ring, just vertically straight down. So if I am going to highlight those two again for a second and show this layer, you see that where these two lines meet, that's actually also where, oops, wrong object selected. Where those two lines meet, that is also where then the two cylinders actually touch each other. And then, of course, you should do this for each side. So I have a point here, a point here, a point here, a point there. But it might still be difficult then to really understand now how, for example, do I have to sketch this? Because if I, as you see, show and hide those parts, you see that from here, this line goes down and goes up. So if I maybe eyeball and try to sketch this line like this, let's see. See, I'm not really 100% correct because you see my orange part actually extends. And if I go maybe this way, yeah, this doesn't work either. So what we have to do is, instead of working just with those midpoints, we also need quarter points. And again, to do this, your best friend again is your cube. So let me show you what I'm doing. So for example, in perspective, I would create diagonals on my rectangles, because as you can see, those diagonals cut my rings. And that is, for example, very important because, hold on 1 second, let me position this point correctly. From there now to the vanishing point, I can draw a line. And I do the same here. So here I draw a line straight down. You see where they meet. Where these two lines meet, I have another midpoint. So now you see number 1, number 2, number 3. And then I have to do exactly the same on the other side. So for example, up here, I would create again a midpoint, a diagonal, another diagonal, and then, for example, when this is my perspective view, I understand that roughly there, I can draw a line to the vanishing point, and the same up here. Of course, by hand, you can easily put your pen to there. Here in the 3D program, I have to make this line more accurate. So let's hide those two lines, two objects, and let's take a look at those lines. I'm going to select them and then actually hide them. Sorry, I didn't mean hide, actually separate them. So if I, for example, take a look at these lines, you see how they're intersecting. So kind of, that's the way how, for example, the piece should look like. And now there you see, now I have number 1, number 2, number 3, number 4, number 5. And let's try to sketch an arc with my mouse, which is not really easy. Let's see how this maybe looks. Let's show my geometry. And you see, actually, I'm already much closer. So as you can see, it's actually not really very difficult to construct two cylinders to intersect each other. All you need to do is just work with your cubes. And here you will see why I'm stressing so much that you really train and perfect your sketching ability to make good ellipses and good proportional cubes, because they're really a tremendous help to perfectly map out this rather complicated shape. And then when you do it, you can work with your midpoints, you can work with your quarter points, and then create those intersecting lines that then help you to figure out where, for example, those shapes will intersect. Then you have the points and you can sketch it out and everything will fit. This was a pretty simple example. Let's go to something more interesting like this. So how do we figure out this interesting intersection line? Now you see, the moment those two cylinders are offset, or if one cylinder is smaller, you start to see that you don't have those pointy edges anymore. So you see, like, the more I move this one out, the more actually now we have kind of like an X And then again, you see nice curves there again. So you see that. And again, using a 3D program is a really great helper to study how surfaces have to intersect. So when you're not sure about how to draw it, build yourself a small model and then evaluate it. So what did I do here to construct this? Actually, pretty much the same. So I created my two cubes, then put my ellipses in. So you can see they are slightly off. And now I need to figure out how do I find the intersection. And again, your best friend first are your midpoints. So for example, I have to do it this way. There's, for example, a midpoint. And for example, this is, again, my 2D perspective. I can, for example, draw this line to the vanishing point. So really long, as you can see. Now, if I go, for example, to my top rectangle and, for example, select there a midpoint, I can't really do the same, and you will see why. Hold on 1 second. So, for example, I draw a line straight down, and it looks like they're cutting each other, as you see. But in reality, if I rotate my view, which I can do in the 3D software, you see they're not really touching each other. And that is because those rings don't really line up anymore. So this looks complicated or no, difficult to solve, but actually we're very close to what we have to do. So let me show you what we're going to do here. So this line I created so that I have, for example, the midpoint. Now I would like to know where this line touches my blue cylinder. And this is actually very easy. For example, here you will see your other best friends, your construction plane. So, for example, I'm going to draft a line down onto the ground and then, for example, to the vanishing point. And you see where it will then touch my blue cylinder. I can actually draw a line straight up. And you see where then those two lines touch. That's actually exactly where they should intersect. And that is where the blue line, the blue cylinder is touching the orange cylinder. Because this is a midpoint of my orange part, and I would like this one to see where, for example, this can touch my blue one. Now, let's see where this midpoint projected to the vanishing point will touch my blue cylinder. See here, I'm going to do the same. So by hand, you can easily find the midpoint. Again, sorry, I have to do something in addition in my 3D program. I'm going to draw a line to the vanishing point. Now, for example, by constructing this, you should pretty much understand the height where, for example, the horizontal cube and how it is intersecting this part. So for example, what I would do to start working, I would create myself kind of like a subdivision inside my vertical box that's defining the blue cylinder. And then, for example, decide kind of like from here. Hold on, I'm going to remove this for a second. Here to here. This, for example, will be the starting edge of my other box going to the left. And to make this one more visible, I'm just moving this one out. So you can see plus minus where, for example, this geometry is. There. And this is really very helpful because you see this line I created from my midpoint that goes towards kind of like this direction. It will touch, for example, this box. So the reason why this is very useful is if I only draw it till it touches this vertical line. From there, if I draw a line straight down till it touches my bottom plane that defines the starting point of my cylinder, and I draw a line to the vanishing point till it touches my blue cylinder, and from there I draw a line straight up, and there you can see where those two lines are touching each other. That is exactly where the midpoint of my orange cylinder is. So you see this? And for example, if I would like in perspective to find the opposite point, I already have half of my work done. So this line is perfectly valid. All I need to do is this line here, I simply extend to the vanishing point, and then where, for example, it touches the blue line again, I draw a straight line up. And there you will see that this line also touches this line exactly where the midpoint of this arc is. So you see again, all I do and work with are actually my midpoints. So let's go to this model for a second. And let's extrude this one further out. Let's move this one to where it should be. And for example, here on this part, now I have to, of course, because in sketching by hand, you can't rotate the part, but you will have to sketch through your object. Again, this is also one of the reasons why really develop a nice ability to sketch gently so you can apply different pen pressures. So here, for example, I have a midline, which I know somewhere on this midline on this box is going to be kind of like this cutting point, but I don't really understand the height. Now, to find this position, you see actually where this box and this line, they're actually on one plane, and you see how it is cutting through this cylinder. So all I need to do is try to find a way to take this edge and project it along outwards. Sounds a little bit odd, but here. let me show you what I'm talking about. I'm going to actually select those lines and bring them out as well, so you understand the design a little bit better. So what I can do now is this line, I know perspectively is somewhere. So those lines go to the vanishing point, and if I extrude them out the other way, they will at one point, as you can see, cut this face of my boundary box that defines this cylinder. And exactly where they cut, if I then draw a line between those 2 points, I see number 1 and number 2 where they cut. Actually the cylinder. And let's rotate and see what happens here. And there you see this line is actually the height where the orange cylinder is cutting the blue cylinder. So here and there. And then with those 2 points, for example, identified, from there, if I then draw a line back to the vanishing point, you will see that these lines will then, give me 1 second, I have to separate them. These lines will intersect this line. So this is like from the blue cylinder, this is from the yellow cylinder, and you see now that this one perfectly rests actually at those poles. So I hope this way you started to see that it's actually always the same repetitive task, trying to work with midpoints, trying to work with quarter points when you have cylinders that cut each other. Because when we want to create a circle, all we need to work with is a rectangle and project, kind of like, for example, hold on 1 second. So what we start working on is diagonal, diagonal, because we know it's 1/3, 1/3, 1/3. We also need to figure out, for example, where are the midpoints. So for example, we draw a vertical, and then we also draw on this horizontally to the vanishing point a line. So we figure out kind of like all those points we need to construct this circle. And well, as you saw, literally, when you want to calculate the intersection, it's pretty much the same. This one is a more elaborate process because this part is offset, but you saw what's really important is that you just work with your boundary cubes, which started to generate the original cylinders really well, and then make use of them to figure out how those surfaces cut each other.